Hey folks, welcome back. We're still working on our P2 transformation parent function stuff. So just a reminder again, my public service announcement, please try to pause and do as much of this on your own as you can. I get it. Sometimes you need to, watch the video for a little bit of a hint. But if you can stop at any point during the video and do this on your own, it's going to go a lot farther. All right, so where are we here? We've got a function. Then we have its transformed function. And we're supposed to figure out what we did to the function, to what would we have to do to the function to turn it from this graph into this graph. All right, that's not too bad. Yet again, when you have multiple choice, I think I talked about this in the last video. If you have multiple choice, go through and eliminate what you can first, what makes the most sense. So tell me something very obvious about these two functions. What did we do to this to turn it into this? What had to have happened? Well, hopefully you said that they reflected. That the one was a parabola pointed, a concave down parabola, and the other one was a concave up parabola. So right off the bat, we should be able to know that our function is going to, one of our transformations has to be a vertical reflection. That means the negative has to be attached to the function. So that has a negative attached to the function. This does not. So I can kill that one. That has a negative. This does not. I can kill this one. Negative this. So look, right now we're already eliminated half of our choices. So if we had to guess, we went from a 1 in 6 chance to now having a 1 in 3 chance. All right, so if you remember when you do a transformation, you have to apply the reflections and dilations first. So we can't look at the shift. When I did this the first time, I went from here and I counted over and I counted over and I was like, oh, we go from 2 down to -5. That should be a shift of down 7, but that doesn't work because you have to do them and you have to do the dilations and reflections first before you can translate. So we know that this thing has to reflect. So this is going to flip to here, right? This is going to be my new vertex. This is vertex 1. This is going to be vertex 2. So that we know that's going to happen. But what happens after that? I want to make sure that this function and this function, I want to see if there's any sort of a stretch, a shrink, a stretch or a compression. So if I move over one spot and I go down, if I move over 2, 1, 2, 3, 4, that's what a parabola is supposed to do. So this is a neither. Remember we used that terminology last year, stretch, shrink, and neither. This is a neither. This is the normal parent function. Now let's look at this one. Here's my vertex. When I go over 1, it definitely does not go up 1. When I go over 2, it goes up only 2. Well, all right, that helps me figure out what my dilation is going to be because this graph went over 1 and it moved 1, then over 2, 4, which makes sense because 1 squared is 1, 2 squared is 4. But this went up something less than 1. I'm going to guess it's probably 1/2, but this one really gives it away. If you're supposed to go over 2 and then move 4, and you only go over 2 and up 2, that means you've done half as much as you did before. So now I can eliminate even more. I know there has to be a vertical stretch of 1/2, or a compression of 2 if you want to look at it that way. And this one doesn't have a 1/2 out in front. So I've eliminated anything without a 1/2 and anything without a negative. Now I'm down to 50-50 if I have to guess. And from here, you even could really just kind of look and just think about it logically. Which one of these does it have to be? The translation goes from x equals 0 over to x equals 3 where my vertex is. Well, that moves forward 3. Well, when you're moving in the x direction, you always want to do the opposite of what it says. Game over. Without even looking at the vertical translation, I know that has to be my transformation. Let's talk, though, why is it -4? Where does that come from? So this is a scenario where once you reflect it and then we multiply it by 1/2, what's going to happen to that height? It's going to go up one spot. It's going to be half as far away. So that distance between 0 and 2 is going to get halved. So now it's at -1. So when I go from -1 over and down, so I go +3 horizontally, which means we want to do the opposite of that. And then we go down 4 vertically, which always means the same. So hopefully that makes sense. Kind of fun. When I did it, the tricky part was I got down to these two, and I couldn't figure out which was which. And then I started to Mr. Wojo and I talked through like why the 4 made sense. So it's always helpful to bounce these ideas off your neighbor. Okay, the graph of f of x is shown. So this is y equals f of x. What is the following could be the graph of f of absolute x? This is easy. You should be able to do this. Go. Pause it. Go. All right, let's see how you did. Who's getting absolute valued? X. So that means all the negative x's are going to have the same y values as the positive x's. In other words, this and this, those two quadrants are going to disappear because those negative x's are going to look exactly like the positive x's. So that's going to mean that all this stuff here is going to get reflected over here. And there, yeah, that's the first one, A. Now, what would this graph look like if it was absolute f of x? Well, you could think about it. Pause it and see if you can figure out which one would be absolute f of x. Hopefully you went with this one. If I took this curve and I did the absolute value of f of x, that means all the y values become positive. So that little section where those y values are negative are going to flip up into the positive section. They didn't ask us to do that, but kind of a good lead in. Or a good review, I should say. Hey, calculator allowed. All right, we finally get to grab our calculator. The number of juniors and seniors at FHS infected with the math bug. Yeah, all right, that makes sense. Math bugs going around. After exposure is modeled by the function m of t equals 500 over 1 plus 3 to the 3 minus t. How many students were originally infected? Well, how many days have gone by if we're talking about the first infections? How many days? Well, none, right? Exposure had just started on day 0. So I would take this function and I would plug in 0. Now there's two ways to do this. Let's do a quick review. Alpha F1, that's this button up here, N over D, that gives us our fraction. So you can put 500 on the top. You can put 1 plus 3 to the 3 minus 0. Now, you get something weird like this. If you want to look what that is as a decimal, you can do one of two things. You can just type it in, and it does it for you. Or, I'm going to bring it back up what we had before. If you don't want to type it in again, math, and this time we're going to, instead of frac it, we're going to decimal it. We're going to turn it into a decimal. But either way, how many students were originally affected? I'm going to say, we'll leave it as... I guess I can... I don't know if I want to round it in a way that makes sense for the story. It doesn't say approximately, so I don't want to say approximately. I need to make a decision here. I'm just going to leave it as 17.857. Couple of things to point out here. In calculus, we always go 3 decimal places. We also never round. We truncate, which means whatever happens after the 3rd decimal place just gets chopped off. The other thing that's very important is you must have a unit attached to story problems. 17.857 would be worth 1 point. The word students is worth another point. So half of the points is comes when we're looking at what am I trying to say? When we're looking at a story problem. How many of these students were infected after 4 days? So this is what, let me show you another trick. I guess I didn't say this. I was started to talk about it, but I didn't actually finish it. So what you could do now is type this in again, or if you know you're going to use an equation a lot in a story problem, sometimes it's best to put it into your grapher. So alpha F1, 500 over 1 plus 3 to the 3 minus x instead of t. Now I'm going to make my window make sense for this story. I'm going to go like, let's say from 0 to 10 days. Remember T, which is X, stands for the number of days. Let's give ourselves a little room. Let's go -1. And then we know we go at least up to 20. So I'm going to go from -1 up to, let's say, 20. We'll count by ones. I'll count by twos. Okay, so there's our picture. Oh boy, it gets pretty big pretty fast. But look at what you can do here. If I hit trace, I can type in 0. Boom, there's that same fraction again. And if I don't like that fraction, format, oh no, mode, I can change this to math print or classic print. I don't have to have it come out to be, if I do classic, watch what happens when I go back here, go to 0. Trace to 0. Oh, it still did it. Oh, that's because I used the fraction thing there. Anyway, okay, so go back to your graph. Let's see how many were infected after 4 days. So I'm going to hit trace. I'm going to go to 4. So there were 375 students infected after 4 days. So my window is definitely not very good because it's after 4 ticks, it should be up at 375. I want to mess around with my window a little bit. So let's go up to 400. We'll count by 40s. What did I do wrong? Oh, I don't care about the X value. I could still go, let's go to 10 days. Going by ones, it's the Y value that I want to change to like 400. I want to look up more on the graph. There we go. Okay, good. So when I trace to 4, there it is way up there at 375. Maybe we should make it a little bit bigger. Let's go to 500. Count by 50s. Trace to 4, 375. When will 200 of these students be infected? Now, this one is really nice because if you don't use your grapher on this, you would have to solve this equation. 500 over 1 plus 3 to the 3 minus t equals 200. Now, we could solve this. Let's see if we could quickly solve this thing. So I'm going to do root switchy. So there's a 1 underneath here. So I'm going to do a switchy there. So I would have then 500 over 200 equals 1 plus 3 to the 3 minus t. Then I'm going to subtract 1. I'm going to reduce this. They both are divisible by 500. So 5 halves minus the 1 equals 3 to the 3 minus t. What kills 3 to the? Hopefully you remembered log base 3 specifically. So now we have, I'm going to go over here, log base 3 of 5 over 2 minus 1 equals 3 minus t. I'm going to do a double move here. I'm going to bump the t over here, and I'm going to take all this stuff and bump it over there. And so I would then have the statement t is equal to 3 minus the log base 3 of 5 over 2 minus 1. So you could solve this using algebra. According to our calculator, this would be 3 minus, now remember, log base 3, I can barely see that, can you? Is that better? Yeah. Okay, log base 3, how do we put that in? Alpha F2. F1 is where the fraction is. Alpha F2 has this log base. Oh, I've got the wrong calc. That's why that wasn't working out before. Not the wrong calc, just the wrong operating system. So, God darn it. All right, got it figured out. Okay, so I'm going to try to evaluate this. 3 minus log base 3 of 5 over 2. So 3 minus. Now I want to do log base 3. That's alpha F2 underneath log base. And so it lets you put the 3 down there. 5 over 2 is a fraction, so I'm going to go alpha F1 again, 5 over 2 minus 1, and we should get some crazy number, 2.630. Okay, so what I want to show you guys, though, if you've got this in your grapher, what we can do, since we can use our calculator, this is a picture of the graph. We want to figure out when is the graph at a height of 200. So I can take my grapher and I can also graph the line 200, y equals 200. Now, where they intersect each other is going to be where their solution is. Now, where they intersect, I can find that underneath calc, second calc, go down to intersect. I have this little blinking cursor. Move it close to where they intersect, and you hit enter 3 times. Once for the first curve, once for the second curve, and once for a guess. And look at your answer, 2.63092, blah, blah, blah. The same thing we got here. So if you didn't want to do the algebra, the beauty of using your calc, being able to use your calc, is that sometimes you can do this on your grapher. So what did we discover, though? When will 200 of these students be infected? We don't say approximately. We say 2.630 days. According to our answer, they didn't say about how many days. Then we could say approximately. They said how many. And so this is what we've got as our best answer. What is the maximum number of students that will be affected? Here again, if you use your grapher, you can really tell this fairly quickly. If you don't have a grapher, if you're going to do this by hand, what's it called when you figure out the maximum number of something or how big something can get? If you remember, that's called the limit. I guess I can put it over here. So this would be the limit as the number of days, t number of days, approaches infinity of our equation, which is 500 over 1 plus 3 to the 3 minus t. All right, so if you were going to try to evaluate this thing algebraically, think about what would happen here as t gets larger and larger and larger. So if I was looking at this, I would say, all right, this section would eventually, if I put t is like infinity, what's 3 minus infinity? Hopefully you would think of that as 3 to the negative infinity. Because 3 minus infinity would just keep getting incredibly, incredibly small. So 3 minus a very massive number would be a very massive negative number, which is the same as, what does a negative exponent do to stuff? It flips it over to the bottom of a fraction. 3 to the infinity is some massively big number, but 1 divided by some huge number ends up being the number 0. Remember, we talked about this last year in terms of a pizza. If you had one pizza and you divided it by everybody in the world, how much pizza would you get? You'd get basically 0. So this term ends up heading towards 0. What's 1 plus 0? 1. 1 plus 0 is 1. 500 divided by 1 is 500. So what's the maximum number of students that will be infected? 500. Don't forget your units. Students. But, like I said, you have a calculator here. So you can go to your calculator, and if you look at the graph, you're like, oh, wait, look what's happened at the top of my graph. As I go further and further out, this is only for 10 days. Let's say we look at it for 100 days. I'm going to count by tens, and I'm going to go a little bit higher on my max. Let's go with like 600. What happens to our graph? It levels off out there. Now, why did it graph that? That's that 200, so I could turn that off or just delete it, and it won't have it anymore. But watch what happens when I start tracing. Day 50, day 60. Now, it's not exactly 500. It says that it is, but it shouldn't. It's just really, 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 really close to 500. So graphically, it makes sense, too, that the number of people that got infected would end up at 500, just like it made sense algebraically. Ooh, this is some good stuff. No calculator on these next two, so put that on the side. Complete the table. Remember how we did this? HA, SA, VA, whole zeros, y-intercept. I'm going to leave this up to you. Pause it. See how much you can get on your own. All right, let's see how you did. This is just one of those basic advanced math ideas. First thing, HA. HA is we compare leading terms. Leading terms. So the leading terms are those two. So is there more x's on the top, more x's on the bottom, or a tie? This would be considered a tie because they're both x squareds. So it's a tie, which goes to the coefficients. So my HA would be y equals 2. If you recall, these two are related. If you have an HA, then you don't have an SA, so we can write none here. VAs, how do we find those? That's where we've got to factor and see if anything cancels. So, VAs they look like this. You have a 0 on the bottom. So you have, this is no good. A whole is when you've got a 0 on the top and a 0 on the bottom. In other words, things cancel. And a 0 is a 0 on the top, but something else on the bottom. So I need to factor this thing first. If you can't factor, so pause, try to factor here. All right, so I tried to factor this, so I took out a 2. That left behind x squared minus 4. I factored this. This is x plus 4, x minus 4. That's dopes. Oops, I wrote plus twice. X plus 4, x minus 4. And then this, notice this can factor again. So I'm going to go 2, x plus 2, x minus 2, and then draw a line through that because I don't want that to count anymore. Anytime you draw a line through something, it's the equivalent of erasing it. Okay, so does anything cancel? Nope, doesn't look like anything cancels. So there are going to be no holes. VAs are things on the bottom that don't cancel. So things that cause a 0 on the bottom. So there are two things that cause a 0 on the bottom. It's when x equals plus or minus 4. Zeros are things on the top that don't cancel, but you have to be able to ZPP them. So this 2 is a scale factor. It's like those dilations that we talked about earlier. That's just going to do a stretch or a compress. So our zeros are both going to occur at the 2's. So that's plus or minus 2, comma 0. And then y-intercepts, what color haven't I used yet? Maybe that light purple. Y-intercepts are found by comparing the constants. Another way to think about it, all y-intercepts have a 0. So put 0 in for x and see what you get. If I put 0 in for x, I'd get negative 8. Put 0 in, I'd get negative 16. Negative 8 over negative 16 is 1/2. Okay, now that we've done that one, hopefully you can go through and do this one. Pause it, give it a try. So the first thing I did was factored it. X minus 3, x plus 1. Bottom is what we call a prime polynomial. HA, leading terms. So I compare the leading terms to each other. X squared over x. That's more x's on the top. That means it's going to launch off to infinity. So there is no HA. But that means that we now have an SA. So our SA, if this is none, then the SA has to exist. So I need to divide top and bottom. So I'm going to do this synthetically. Remember how we take this, ZPP it, put it in the box. 1, negative 2, negative 3. The 1 drops. That's negative 2. That's negative 4. That's positive 8. That's 5. So this was an x squared. So this is going to become 1x minus 4. You can ignore the remainder, and there's our HA. Y equals x minus 4. VAs, things on the bottom, they have to cause a 0 on the bottom. VAs are very bad. So if you get a 0 on the bottom, life is not good. So what X value would cause a 0 on the bottom? That would be -2. We don't have anything that cancels again, so we can just go ahead and say that we don't have any holes. Zeros are the things in the numerator that do cancel. So we have, that do not cancel. In other words, they cause a 0 on the top, but don't cause a 0 on the bottom. So that would be the number 3, 0, the 0.30, and -1, 0. And y-intercepts I like the best because it's always 0, comma something. So if I put a 0 in here, 0 in there, 0 in there, those are all dead meat, and I get -3/2. If you want to write 1.5, -1.5, you can. You don't have to. Okay, so here next up, we're going to talk about this thing called a sign chart. Now, we use a sign chart a lot when it comes to inequalities because we're comparing a bunch of different things. If this was equal to 0, I would ZPP each one of these because if you put -2 in here, what does that make this thing? 0. And what's 0 times anything else? 0. But we're not trying to figure out where there are zeros. We're trying to figure out where things are greater than 0. Well, then should we just ZPP them all and just write greater than 0? No, because what if this is negative, this piece is negative, and this piece is negative? What's a negative times a negative times a negative? A positive. Well, what if we just made them all positive? Positive, 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 right? That would work. But if this is positive, and this is negative, and this is negative, then that's still positive, so that works. So what you need to do is you need to compare where these terms are positive and negative, and we use something called a sign chart to do that. So this is a sign chart. So a sign chart, you have a number line. And on the number line, you're going to identify where all the zeros are. So in other words, you're going to ZPP this. So there's going to be a 0 at -1. There's going to be a 0 at 3. There's going to be 0 at -2. So I'm going to have 3 zeros. Put them in order: -2, -1, +3. Now I'm going to look at the values of each term individually. So if I look at just x plus 1, if I pick a number that's smaller than -2, like -1,000, and I plug it into this, what kind of number do I get out? -1,000 plus 1 is still negative. So that section is negative for this factor. Let's pick a number between -1 and -2, like -1.5. -1.5 plus 1 is still negative. Pick a number between 0 and 3. My bad, -1 and 0. -1 and 3, I'm going to pick 0. What's 0 plus 1? Positive. And let's pick something 3 or bigger, like 1,000. 1,000 plus 1 is positive. So for this factor, depending on what number you pick, will cause either positives or negatives in each section. Now we're going to do the same thing for x minus 3 cubed. So let's pick something like -5. What's -5 minus 8? What's -5 minus 3 is -8, and -8 cubed is still negative. Let's pick something between -1 and -2, like -1.5. That would become -4.5, and a negative times a negative times a negative is still negative. Let's pick 0. 0 minus 3 is -3. -3 cubed is still negative. And let's pick something bigger than 3, like 10. 10 take away 3 is 7. 7 cubed is some big positive number. So that section is positive. That's the way that factor breaks down into positives and negatives. And then last, I'm going to look at x plus 2 squared. Now, what's nice about squares, what happens when you square anything? It becomes positive. So let's pick a number down here like -3. -3 plus 2 is -1, but -1 squared is positive. -1.5 plus 2 is 0.5. Squared is positive. 0 squared is 0, but Oh no, 0, put 0 in there. 0 plus 2 is 2. Squared is 4, positive. Anything bigger, positive. Now we're going to look at each section as a whole to decide whether or not this product of all these things are positive or negative. So what's a positive times a negative times a negative? That's positive. I like to circle the ones that are actually part of the answer. A positive times a negative is a positive. Positive times a positive is a negative. Positive, positive, positive is positive. Okay. So for this function, for this expression here, this is where things are positive or negative. We want to identify all the ones that are greater than or equal to 0. So we would say all the x's that are an element of all the positive sections. Well, positive greater than or equal to 0. So from negative infinity up to negative 1. Include it because it could be equal to 0. Then from negative 1 to 3, we don't want to include any of those. And then from 3 to infinity, oh boy, what do you think? That's not easy. That's not easy. I'm going to pause here for a minute. I would like you guys to try to do part B. It's the same thing except you're dividing. So, the chart is going to be the same. You're just going to think about it in terms of dividing instead. And I'll come back and help you. Okay, let's see how that next sign chart problem went for you. So I've got to first figure out where my zeros are. So if I ZPP this, I get 3/4, x equals 3/4. ZPP this, I get x equals negative 1, so I have 2 zeros. Negative 1 comes before 3/4. Now I'm going to do a sign chart on these two, which means I need to look at each one of them separately. So x plus 1. If you pick something smaller than negative 1, you're going to get a negative when you plug it into x plus 1. I plug in 0, I get a positive. I plug in 1,000,000, I get a positive. I'm going to do the same thing with 4x minus 3. Negative 1,000,000,000 would be negative. 0 would be negative. 1,000,000,000, 4 times 4 billion minus 3 would be positive. Okay, a negative times a negative is a positive. A negative times a positive is a negative. Positive and a positive is a positive. So I want to figure out what sections, what x's are less than 0. So those are the sections that are less than 0. So between negative 1 and 3/4. This time I do not want to include because this is less than 0, not less than or equal to. So I'm going from negative, all x that are an element of negative 1 to 3/4, not inclusive. And then last one, calculator allowed again. These are just some quick reviews of how to combine some stuff with some of your log properties and then how to do a substitution. So in this scenario, when you have this, I don't know if you see this like I do. I've done a lot of these, so I get it if you don't. But I recognize this is really a quadratic equation. It doesn't look like it, but this is a quadratic. This is x squared, this is x, and this is some constant. So what we're going to do first is we're going to sub out. We're going to say let y equal e to the x. So now e to the 2x becomes y squared. We said e to the x was y minus 12 equals 0. So we've taken this ugly looking problem and we've broken it into something that's pretty straightforward. Now I can factor this. Y minus 4, y plus 3 equals 0. ZPP, y equals 4, y equals negative 3, but we don't care what y is. Y was something we created to help us. At this point, I'm going to take what y is and put back in e to the x. So e to the x equals 4, e to the x equals negative 3. And now I want to finish this by solving these equations. So what would kill e to the x? Oh, come on. What kills e to the x? Natural log. So I'm going to natural log everything. So natural log and e to the cancel each other out. I'm left with x. Natural log of 4 is, I'm just going to write natural log of 4 for now. And then over here, I would get x equals natural log of negative 3. So natural log of 4, calculator allowed. Now you could leave this as natural log of 4. You do not have to actually calculate it unless they say that you have to put it in its decimal form. These are acceptable answers. And what's weird is if you do the work right and then you write down the wrong answer at the end, you can still lose points. Like half the points. It's crazy. It's a lot. So I'm going to write down, I'm going to truncate, not round. So this would be 3 decimal places, 8386. And then now let's try to figure out what's natural log of -3. And we realize that doesn't work, which makes sense because you can't natural log a non-positive. Remember the graph of natural log? Goes like that. It doesn't live over here in the negatives. This is what we call an extraneous solution. So we wouldn't even box it in. You could write EXT solution if you wanted to, but you wouldn't have to actually finish it. Okay, moving on. Let's remember your log properties. Log of something. Log, subtract a log. They can condense. Do you remember your condensing? See if you can remember. How do you rewrite this? Pause it and try to rewrite this. Hopefully, you wrote something like this. Log base 3 of x plus 4 over x minus 1 equals 2. So when I have log minus a log, I can condense that into a single log using division. Subtract and division go together. Now, if this was a plus, I would do x plus 4 multiplied by x minus 1. Add and multiply would go together, but this is a subtract and divide problem. Now it comes pretty straightforward. Who's farthest away from x? Well, I've got 2 x's, so but before I can get to either of them, I got to kill off this log. Log base 3 is killed by 3 to the. So I now have x plus 4 over x minus 1 equals 9. Now I'm going to do a cross mult or a switchy if you're a root person. You could do a switchy here. Either way, this is going to get multiplied by 9 when I distribute. So I got x plus 4. 1 times x plus 4 is x plus 4. And then 9 times x plus 1 would be 9x minus 9. I'm going to move this over here. I'm going to move this over here. So 9 added to 4 is 13. X take away from 9x is 8x. Divide both sides by 8. We get x equals 13 over 8. This one I'm going to leave. If you divided it out, let's see if we'd even have to, yeah, we wouldn't even have to round or truncate. It came out to be 1.625. So either one of those are fine. I'm going to stop there this time. All right, last but not least. Oh, this is kind of interesting. All these logs, just kill off one at a time. Who's the farthest one away? Log base 2. What kills log base 2? 2 to the. So now we have log base 3 of log base 5 of x. What's 2 to the 0? You do not need a calculator for that. 2 to the 0 is 1. Anything to the 0th power is 1. Now we're going to kill off the log base 3. Log base 3 is killed with a 3 to the. 3 to the. Those cancel, and so now I have log base 5 of x equals 3 to the 1 is 3. Then we kill off a log base 5. Log base 5 is killed by 5 to the. Yeah, this one you didn't need a calculator for at all. X equals what's 5 to the 3rd? You should probably be able to figure that one out. 125. Okay. So hopefully that helped going over some of it together. And as always, if there's anything more that you want to talk about, we could hash that out in class. All right. Good luck.